Hello, welcome to LabVIEW assignment number 3. In this LabVIEW, we were asked to utilize a push button, a numeric display, and a stop button on a front panel, and then configure the mechanical action of the push button as a switch until released. So if we look at the switch here, I changed the mechanical action from the default, which is switch when pressed, to switch until released, which then forced us to have to use a event case structure rather than just a case structure, as we have been using before in the prior LabVIEW assignments. The conditions that this virtual instrument has to operate under are as follows. When the VI is running and the push button is pressed and released, the numeric display should start increasing by 5 every second starting from 0. So once we start our program here to the left on our front panel, and now we are running it, we're going to click it. Now, upon the click, it's not going to do anything. The program is going to run, but it's not going to actually increment the count until the release itself occurs. Now, once I released it, it now is going to increment the count 5 every second. And you can I added this Count Discrete-Time Plot so that you can see internally what is happening. It is every second it is incrementing the count by 5, which meets the requirement where it is supposed to be increasing by 5 every second starting from 0. Now, where the numeric display count is increasing and the push button is pressed and released, again, the numeric display count should start to decrease by 2 seconds until by 2 every second until it gets to 0, and then the display should stay at 0. So if we click this and release it again, now we're going to see that the count now is decreasing by 2 every second. And you can see once again in our Count Discrete-Time Plot that every second the count is now decreasing by 2. And if the next case is that if the numeric display is decreasing, but it's not yet 0, and the push button is pressed and released again, the count should start to increase by 5 in that fashion. So as it's decreasing right now, and we press it and release it again, now it's going to start increasing again. Now I'm going to press and release it again so that it can start to go towards 0, so that we will also meet this condition, which the second requirement requires, which is decreased by 2 every second until it gets to 0, and then the display should stay at 0. So there is logic involved within the block diagram that forces the count to stay at 0 and not have negative values displayed on the count itself. It holds it at 0. And we will be able to show this very shortly once the count gets down there. Another thing is that the user should be able to stop their program using the stop button. The stop button is located right here, and when the user presses this, it'll terminate the program immediately at that point. Some other things that I added to this assignment while we're waiting for this count to go down is I added a lot of I call it artistic flourish to the front panel, so that it kind of I colorized the different buttons and match the plot itself to kind of match it so that it would be a more professional look. That just another thing that you can add some flair to your virtual instrument design projects. And now we're finally getting to our count, and as you can see, count is finally getting to 0, and then once it gets to 0, it stays there. Now I'm now going to open up the block diagram by pressing Control E, which will open the block diagram. And in here, we're going to start first with our timeout case. What this does is I decided to use 3 shift registers, one in charge of the count read, one of the step, and one for the stop, which then sends the values through the entire while loop and loops back around again for each of the 3 shift registers. These are the read cycles, and these are the write cycles over here. Inside, I used a event structure. For the timeout case, it takes a value in here in the stored count, and then it takes the adjustment either +5 or -2, and then it adds them together here. And then if that value, this arithmetic block here evaluates it, and if the value is greater than 0, then it will pass that value through. If the value is less than 0, then it will go and clamp that value at 0 and then output that to our indicator block here, which is on our front panel, or to our graph, which is our discrete time plot, which was not part of the assignment, but I added here just to add a nice visual display touch to this. I also found that I could run this highlight execution thing to kind of see the signal flow through our while loop and our event structure here. And if you look at this, you can see the value right now from earlier. It's being held at 0. So every time it's trying to go further down, but this is our stored count is at 0 here, and it's forcing it to be at 0 and not allowing it to go up higher. As you can see, that it's evaluating it and then it's outputting 0 instead. It's been running this entire time. Now, if we go and hit Control E again, and we go back out to our front panel, and we were to start the run again, you'll be seeing that it will be running this, and it's going to start going up. It's going to increase this value here, and now it's going to output the larger of the two, which is now coming from the summing junction, basically right here, the summing arithmetic block, and it's going to evaluate that, and then it's going to output that number instead of the value that's held at the clamp at 0. So now if we go ahead and we were to go and hit this stop right here, it's going to stop the entire program wherever the count's at immediately. And it shuts down the entire program, which meets the last case requirement for the assignment. Now, we are now looking at the switch case. So there's two cases, which is being evaluated with the event structure. The first case is let's look at the false. That doesn't matter. Let's look at the false case first. Like I was saying before, it's only on the release that that it's being changed. So if the count is coming in as a 5, or if it's being incremented as a -2, depending upon that value that's coming in, if that statement is true or false, then it's going to change to the other increment. Either it's going to decrease that value, or it's going to increase the value depending upon what it was originally coming in at, but only upon the release. If it's not when you press it down, it's just going to send it straight through here using tunneling straight through the entire event structure and the case structure, and it's not going to change anything. But then if it's on the release that it's going to change depending upon the prior count that is coming through here. Now, if you go to the last case, which is our stop case, this is the only event structure which is true for the stop button. I mean, basically the stop button. Once you click it, then it stops the whole program. For all the other registers here, it doesn't do anything. It's just sending it right through here because nothing's being updated on it. So basically, when it is shut down, the whole entire program shuts down, and whatever value stored in the count and everything, it's stored in the count. It just stays on the screen because it's a complete shutdown. It doesn't clear to anything. Now, you could have added, or I could have added with some logic, I could have had it clear that maybe, and have a delay or something, and then it shut down the program and close it out to 0. But as that wasn't a requirement, I did not add that functionality. But it is something that you could do, but then again, in real life, you may not want to have, in a safety situation, you may not want to just clear out a digital display or some analog display that is showing some process. It's more important to have your process completely terminated so that there's no delay between the act of ending a process and actually the process coming to a halt, because some people could get damaged or product could be destroyed. So it's better to just have it, for many and most applications. I would think it's better to just have the process terminate where it's at immediately. It's like an emergency throw, and to turn the shut down the whole process. And that is pretty much everything that I wanted to talk about in this one. Well, maybe the only other thing is that the time to control the 1 second specifically, what I used was this. I took 1,000 and divided by 1,000 milliseconds, which is what it's set at. And by doing that, by inputting 1,000 here, it runs the event structure every second. And by adjusting this, you can determine how often it will go and run the events in here. So if you increase this to 2,000, then it would run the events every 2 seconds instead of 1 second. And another common practice I found out was that you don't actually wire in your switches and your buttons and stuff from your panel. That common practice is to have them aligned outside your event structure on the left side here, that they're unused, but the compiler uses them, but it's actually not wired in. That your while loop itself and the way it's set up, it actually handles the actual operation of the switches and stuff. It's handling it so that the actual switches icons down here don't actually have to be wired into your event structure directly. That's something that you may be helpful if anyone didn't know that already. So I hope that you enjoyed this LabVIEW assignment, and hope to see you again, and enjoy and keep learning more new and exciting uh, things in LabVIEW. I'll see you again.